Hello, everyone. I'm Curtis Yanko, Director of Global Alliances and Strategic Partnerships here at Sonatype. Today, we're going to talk a little bit about our relationship with Micro Focus and how we bring software composition analysis in that partnership. The structure of this talk is we're going to go over the problem domain first, what it is we're talking about. Then we'll talk about our joint solution with Micro Focus after level setting on what Sonatype itself does. And then from there, we'll just go through some of the reasoning and why this matters. So I like to start my story with a reminder that the A9 has been on the OWASP top 10 since June 12th of 2013. And this is a fairly memorable moment for myself in that just a couple days prior to this, I was able to join our CEO, Wayne Jackson, on the stage at a Gartner Security Summit. It's interesting timing in that a couple of things. One is Sonatype was there with a solution as this became a thing. Sonatype was aware of it and working on it and bringing it to market. And it coincided with the OWASP realizing that the growing number of attacks were using this attack vector and deciding to include it on its list. We were at the National Harbor in DC, and this summit was populated by a lot of government agencies and the likes. And it was also the same week that the Edward Snowden news came out. So it was a really interesting time to be in DC talking about security. The reason I like to bring this up, though, is a couple. We still find through our surveys and stuff that a lot of folks still are not addressing this critical element of the OWASP top 10. When we talk to customers, they're either doing nothing or maybe they have a process, but it's largely manual. So today we'll dive into some alternatives to that. This is a slide that we generally use to talk about the history of our company, but I want to focus on a narrow part of it. So while we were founded by the co-creators of Apache Maven, which brought third-party dependency management in a predictive or in a declarative way, that's the word I'm looking for, to the Java ecosystem, it also meant that we then were the creators of Maven Central. Then we had a product, Nexus repository, that we started bringing to large enterprises. And when we showed up thinking, here we were with our great technical solution that kept things fast by using proxy caching technologies and this declarative dependency model, what we quickly learned is those customers really were interested in governance. So while it was great to have the technical aspects that we brought, what they were most interested in is how do we control who uses what and what are the reasons that they can or shouldn't be using those components. So it was a real eye-opener, and it started us on the path that led to the product that we'll talk mostly about today, our lifecycle product. And it was that same product we were talking about on the stage at the Gartner Security Summit back in 2013. Now, at the core of this problem domain is the simple fact that the open source ecosystem is massive. And I updated this slide from last year's numbers to this year's numbers, where we can see there's essentially 21,000 new releases every day of open source components across all the various ecosystems, or at least the handful of the largest ones. That's a staggering amount of new components coming out every day, and it's hard to imagine any small AppSec team being able to keep up with that. We see it ourselves as the stewards of Maven Central. We've seen the growth in the downloads from Maven Central with 146 billion back in 2018. We should pretty soon have some 2019 numbers before long here. But a lot of this is being fueled by the fact that everybody is, doing agile, continuous integration, DevOps, you name it. Bottom line is people are doing 10 builds a day instead of 1 build a week. And so we see that being reflected in the download count. So just a sheer massive volume of components being downloaded every day. That's just Java components. If we take a look at the NPM ecosystem for JavaScript, this one says 7 billion, but you'll note it's a weekly average. So you have to multiply that by 52 in your head to come up with the staggeringly large number of components that are flowing out of that ecosystem. And even if we just stop at those two ecosystems, what we know firsthand here at Sonatype is we're not necessarily building quality in, and this is a key uh, concept that we'll sort of revisit several times throughout this talk. And we know that because we know that 1 in 10 of those downloads is of a known vulnerable component, essentially violating that OWASP A9. So that's not great, right? JavaScript's much, much worse. This is from, the source is NPM themselves, and they believe as much as 51% of all downloads are of known vulnerable components. And so to just get to the crux of the problem domain in this context, there's really two things going on here. The first might be not well known to most security professionals, but apps on average are about 80 to 90% made up of these open source libraries. So that's a really staggering amount. The good news is that although open source brings a lot of productivity to developers, it takes a lot of work off their plate, so they don't have to write how to log to a file, talk to a database, or the latest model view controller framework or whatever that is. But you end up with a situation where you have this iceberg. Your developers are writing the part of the iceberg that you can see, but there's this hidden 80 to 90% underneath the waterline that we don't see. And so, we're not the only ones to say this, but this is the mantra throughout the industry. Security has to shift left and be integrated tightly into development. We have to catch these problems early if we're going to make a difference. So let's move on to the solution with that in mind. First of all, let me just introduce you to the Sonatype Nexus platform and what we do. I see our auditor product already on this slide, and that's really geared at legacy apps that don't have active, that don't have SDLC active. And so, my definition of legacy is apps that are no longer funded by the business. Therefore, there's no development and they're not flowing through your pipelines. They're just running in production, right? But more importantly, we have this solution called Firewall that it acts like, your security team at the front doors of your office, making sure that people entering the building should be entering the building. They have a valid badge that's not expired, and they're employees. And so our Firewall product is similar in that it inspects these components entering your organization. And if they violate your policies, most notably, have a known vulnerability, we can quarantine them immediately and provide that feedback to the developer. And that can be a big deal. It can prevent them from even starting any kind of proof of concept work on something that's known bad, right? We'd hate for them to invest a fair amount of time and only to later learn that they can't really use it and have to start over. So nipping this in the bud is fairly crucial. Next up is our lifecycle product. This is our flagship product. And this is designed to cover the entire SDLC, at least from construct, the active coding and development, all the way through to your apps are in production. The idea is we want to provide feedback early in the process without breaking it, but then give delivery teams the option of where to break that pipeline through using an automated toll gate later. The other byproduct of all of this is it allows us to track and trace which components are in which apps that are actually in production, where we can use our continuous monitoring technology to alert you to any 0 days. So even though we're blocking at the front door, these components go bad over time. So yes, they could have been perfectly fine when they entered your SDLC, but over the following weeks or months or years, they tend to go bad. And our last product, which is actually our first product, was the Nexus repository itself. This is a key component in any SDLC. And it just, it acts as a single source of truth for your binaries, all the binaries that you're borrowing, I apologize, and all the binaries that you're building. So oftentimes after you build and package things, they're moved into a repository, and then they are from there deployed to various environments. It's also used up front for proxy caching these components that are allowed through the firewall, so that next time you ask for it, you don't have to reach out to the internet across your wide area network and drag it in. All right, so if that's us, underneath the hood, and what makes all this really usable is that it's supported by our data team. We have 65 dedicated security professionals who do nothing but security research. They're supported by an additional 30 folks who do all the AI and ML type automated vulnerability detection system. So that system essentially looks for any conversations happening on the internet around open source development. Think forums, Stack Overflow, GitHub commits, any of those things, any advisories, anything coming out that could be potentially related to a security issue is bubbling up to our security researchers. And this is important because I'd like to highlight the fact that, I believe the National Vulnerability Database just had its 100,000th CVE entered into it, and that's over the life of it. But here you can see we've got 1.4 million IDs in our system that aren't in the National Vulnerability Database. And the problem there with the National Vulnerability Database is that it's really an opt-in system. It requires the development team developing these components to report, to just go and report that they have these issues. And while they often do, there's often significant delays in when they do. Many teams don't report at all, simply fix it and move forward. So there's really a lot of gaps in the National Vulnerability Database. So really what we're doing here is we're just using a lot of, Amazon compute power to help us tease this out. But at the end of the day, those human researchers look at the commit that introduced this, the commits that fixed it. They actually analyze the code down to the class level and provide a really detailed write-up that allows developers and security professionals alike to better adjudicate which ones need to have action taken, which ones maybe don't need action right away, and just all those sorts of things. So really, this is what underpins everything, because we want to automate. And without precision data, you can't automate against bad data. You'll just have a noisy automation that requires humans to come in behind it and train it or do whatever, right? We want a system that you can rely on out of the gate. And so our data team makes that possible by having the most precise intelligence on components out there. Here's just an example of what I was talking about in terms of our data. This is the CVE that was in Struts. Obviously, this is a very well-known vulnerability at this point. It made the headlines for all the wrong reasons a year and a half or so ago. But here you can see the description that would have been in the National Vulnerability Database. And here's the description from our researchers, really getting down into what's happening, which files and classes these things are happening in, how to know that you're affected, and sort of below the line here on the slide is our recommendations. And even though we say you got to get off, you should get off this version, there are some workarounds available with changing some of the default behaviors of this class or overriding it. And so all that's spelled out. And this is the kind of actionable intelligence that allows security and developers to really work together in making sure that we understand what's in our apps and that we're minimizing our risk before they go out the door. The other key component to our solution, based on what I just said in terms of our research team, and this comes as probably a surprise to a lot of security folks who are very used to false positives, but we have no false positives, right? Because we've taken the time to do the deep analysis, we're not going to report on a component that isn't actually vulnerable, right? There's even data in there in our categorization that lets you know whether or not it has to be on your call path to affect you. A lot of people think, well, I have vulnerable code, but I'm not calling it. But the truth of the matter is many of those vulnerabilities are accessible even without being on your call path. So you have to be aware of that detail as well. Techniques like reflection and stuff will allow exploits to use code that you're not using. So this is an important concept, and it's what makes our automation possible. The second bit is that actionable intelligence I just talked about. This is the key, another key ingredient. It's not enough to say, hey, you've got a problem. We have to tell you what the path forward is, right? So actionable intelligence is really critical. So with that in mind, now let's look at it in context with our partners at Micro Focus, and in particular, their Fortify platform. Our software composition analysis, not to be confused with their static code analyzer, I apologize for that, but we have Forrester to thank. But it's a perfect complement to their static analysis tool. So here I'm using the SAS acronym to avoid the overlap, and their dynamic testing tools, right? So this completes the picture of application security. And while many teams are already doing static and dynamic testing and thinking, well, hey, you know, that scan should be covering all my code, and then we're running it, it lacks the information of knowing specifically what components you have and what's known about them. This becomes an easy target to drive down risk and with a lot less overhead in terms of doing the analysis of the code or call flows or any of that stuff. You can just simply remove known bad components and replace them with components that don't have known vulnerabilities. And that's a really simple, easy task to do back there in the construct phase, you know, or as I like to put it, in sprint, and before it leaves that agile release cycle. Here's a quick screenshot showing how we're integrated into FOD. So if you're uploading packages to Fortify on demand, and you're doing Java, .NET, JavaScript, or Python at the moment, there's a checkbox available for you to add a Sonatype analysis to your scan. I'm at the time of this recording, Go should be out in sometime in November or so. So Go language will be added to that in the near future. So this makes it simple and easy to include this in your Fortify on demand scans. The other big change that happened this year in 2019 was Fortify on demand updated their dashboards to make data from third-party dependency analyzers like our own first-class data. So this now rolls up into your dashboards. In the past, findings from those types of scans would have been basically partitioned off into separate reports, and they would not have flowed into your dashboards. So you weren't really getting a complete view until, I think, starting with the 19.1 release. This data is a first-class citizen, so that's good news for everybody involved. Here's just another view showing I had a demo environment of Fortify on demand, and I was able to include our scan in it, and so you can see all the new open source stuff. So this is just an example of showing that these types of findings are in fact rolling up into this dashboards, and and trending and that sort of stuff. There is also a global SCA view in your Fortify on demand instance, this little block over here. And this is an important one because this gets to another crux of the problem, which is here we can see every component that we've analyzed across all of our apps. And at any time, if we want to, we can click and see all which apps they're in. So this is a small demo instance. I've only got things in a couple of apps. But that's a really important concept for when those 0 days come in after they're already into your applications, perhaps after they're already out in production, right? We want to be able to very quickly take that 0 day information and immediately communicate the impact of that to our organization so that we can begin thinking about prioritization and remediation, right? Without this capability, we hear from many customers and IT shops out there that they can spend days or weeks in discovery just trying to find out where that struts component, if struts is being used, and if so, where. That can be a long process if you're not tracking where these components go and giving yourself an easy lookup tool like this. Here's our Fortify integration. Sorry for my video cutting off a bit of the text up there. But this is for the on-prem solution. So really what we have here is a plugin that goes into your SSC instance. And then there's a separate service that sits in between the IQ server and SSC. And based on a mapping file, it's extracting data from IQ. And that mapping file tells which app at which stage in our system belongs to which app at which version in Fortify Software Security Center. So there's an on-prem solution as well. I think we'll see this evolve rather quickly in the coming months as we've been updating our API to better facilitate this. We're also adding mechanisms to automate the addition of new apps into the mapping file to make it easier to automate and onboard things. So that's how we integrate today. But what gets me really excited as someone who's worked with these folks for a couple of years is the idea that our security team is now in a position to collaborate with and work closely with the Micro Focus security team. And we have a couple of large security teams that are very, very smart. Their team obviously very focused on static code analysis and dynamic testing, and are really pushing the envelope on that front. But what we're finding is, even if we start to combine our data in elementary and sort of things that you would reasonably expect, just using information from our scans to inform a static code analysis scan, we're finding that we can get really interesting results. And I think in the not too distant future, we'll start to see some real benefits of that kind of sharing between our data teams, and ultimately between the data the tools are finding to inform other tools as they do their work. Knowing there's a known vulnerable component could inform, our static analysis can decide if it's on the call path or not, if that's the actual issue. It can also help inform dynamic testing, right? Maybe it can help narrow down those pen test type tests to exploit known vulnerabilities, to ensure that these things are being found and not passed down the SDLC. So let's get to the reasoning bit. This is the last bit. So we talked about the problem, the OWASP A9, our platform, and how we integrate with Micro Focus. But why do we really care about these, besides the fact that they're on the OWASP top 10? And one of the big things that strikes me in particular, as someone who's been working in this space since well to the left of this chart in 2006, I think my career started in the mid 90s with build and release management and SCM, long before all the fancy new stuff was out. But I also remember we used to feel like, active exploits didn't come out for nearly 30 days. Even then, not everything had an exploit. So security teams would largely rely on intelligence that let them know if there was an exploit in the wild, and they could use that information to suppress a bunch of findings. So yeah, there's this vulnerability, but if nobody's taking advantage of it, who cares? Fast forward to 2017, and again, that very famous incident involving struts, we saw that the exploit happened within 3 days of the vulnerability being announced. To me, this is really interesting in that I feel like the bad guys are doing DevOps better than we are. They were able to quickly turn around an exploit package and get that in their production, if you will, and start attacking our systems in 3 days. So we can no longer really rely on waiting for the intelligence of whether or not an exploit has an active exploit, because you don't want to be the first one to find that out and share that data back to the other folks, right? You don't want to be the one finding out that there's a new exploit in the wild because you've been compromised against a vulnerability that you chose to ignore. So it's just the sheer time is the big difference here. And in that same year, though, one of the guys in the security community at the NSA was at, I believe it was Black Hat or one of those type of conferences. It says they're routinely seeing attacks against them within 24 hours. Obviously, they're a very rich target. And so it stands to reason that they're being attacked first, because the hope is they're faster than we are, right? So one of our challenges is we have to automate faster than evil to keep these guys out. But just know that these vulnerabilities are very real, and exploits are happening within days of the responsible disclosure of the vulnerability itself, which tends to happen only a couple of days after the patch has been out. So it's really important that we can find ourselves in a place where we can patch within a day, right? The day that we find out, we need to be able to that same day get another release out. The other part of this I'd like to point out in the reasoning is, if you're not tracking and tracing these components, especially with automation, even if you have a manual process, we often see that developers go around it. But if you're not actively managing it, it means every developer in your organization is essentially in procurement. And coming as someone who's worked in 2 different Fortune 100 insurance companies, that's just mind-boggling, because we know that we can't buy anything without going through a lot of of policy, right? We have to go through a lot of process and procedures, build up our a scorecard on how we're going to evaluate multiple products, and then go in front of a committee to get approval to bring that technology in, right? But here on the flip side is we have developers who are allowed to go pick anything, and that's great. I mean, I actually think they should, but if you're not actively managing it and giving them feedback, it means they're literally just picking anything, good or bad, versus picking anything, getting feedback, and then adjusting to something that's good, right? So they're in procurement whether we like it or not. We just got to give them the information they need so they can be in procurement and do it well. And so this gets down to why Sonatype exists, right? This has been really powerful for me as someone who was a former practitioner prior to coming to Sonatype. But tools like Lifecycle allow security to express their policies in a way that can be shared readily with the developers and the tools they're already using. And at the same time, allow them to work closely with the ops folks around those 0 days by having immediate understanding of the impact. That might immediately trigger other ways, other compensating controls with firewalls or whatnot, right? So now you're partnering with them to keep things secure. And that's really what we're here for, is to pull all these folks together. And while we came at it with the developer mindset in mind, it really the nature of the solution has allowed it to be flexible enough to really foster the kind of collaboration that DevOps is about. It allows security to get out of their silo and collaborate with both delivery teams and operation teams when it comes to application security. So when we talk about software supply chain management, we like to talk about it. It's a new yet proven way of thinking, because this all comes from the automobile industry and Edwards Deming, right? So all of this has been proven to work in the physical manufacturing space, and there's every indication to say it has a profound impact in our software space as well. We want you to source parts from fewer and better suppliers. Our recent State of the Software Supply Chain report talks about projects that are exemplars. We should be pulling components from the projects that are detecting and remediating their own problems quickly, right? And there's a lot of components out there that can take 180, 200 days before they're detecting and fixing their stuff. And that's simply unacceptable in today's world of going really fast with software. So we want to help you source parts from fewer and better suppliers. And then when you do, we want you to use only the highest quality parts. In the manufacturing world, this became partnerships and providing feedback with those manufacturers about how to maybe alter design slightly to better fit or be easier to maintenance or improve their durability, whatever that was. Fortunately, we live in a world where this open source allows us to go back and contribute back to these projects and make sure that they're performant or provide the features that we need. So not only can you use the highest quality parts, but you can actually partner with those suppliers and make sure they are the highest quality for your specific use. And then here's the key one: never pass a known defect downstream. This was really what Edwards Deming revolutionized the industry with, by building quality in, stopping automobile manufacturing assembly lines to understand problems and essentially learn from them in a way that ensured that they didn't happen again, right? So that we were building quality in and not letting those defects go down the assembly line and ultimately out to the end users or consumers. And another key component of all of that was to continuously track the location of every part. In the automobile industry, we recognize this when they have their recalls. They don't perform a recall and say, all Chevy owners, please bring your car in so we can see if you have the bad brake pad in it, let's say, or airbag or whatever that is. No, what they know is they know which batch of brake pads is bad and exactly which VIN numbers those went into, and then they send a letter to those owners letting you know that you've had a recall and you should bring your car in. That's much more cost effective, right? Instead of having everybody come in and using an inspection process to determine whether or not you have a problem, because we know where the parts are, They know exactly which cars to bring in. And I hinted at this earlier in the world of software. When those 0 days come out, you want to know exactly which apps are affected so you can immediately communicate that risk and impact back to your teams and immediately begin implementing compensating controls or patch releases. So it changes everything. In the old world, you could use any open source, but we were doing it blindly, right? And I still want folks to be able to use any open source, but I want them to get immediate feedback so that they can embrace only using the highest quality open source. Historically, especially teams with manual approval process are relying on quick and dirty research, although quick and dirty could often equal 2 to 4 hours of time. But what we're suggesting here is that you can rely on expert automated research on your fingertips. We have those 65 folks doing all the heavy lifting, so you don't have to. You should just have this information available to you via a quick search. We want to help security teams stop being seen as an obstacle to innovation, right? Security slows everybody down. Security just gets in the way. And we feel that we can help elevate security to becoming a partner in innovation by communicating, like I said earlier, policies through tooling that provides actionable feedback at an important moment early in the life cycle, throughout the life cycle. Right. So now if we're not passing these defects downstream, that's great. And we're also in a position to deal with those 0 days. Security now is seen as a partner in making things go fast and helping create the capacity to perform innovation instead of doing rework. We want folks to stop resisting governance, right? Developers are really smart. If things get in the way and slow them down, they're pretty good about going around it. But we feel that once they have governance-infused tools, they'll be willing to embrace it, right? Getting that kind of feedback that lets them, while they're thinking about it, make a simple, let's say, version number change to a new component will help them feel like this is helping them avoid tickets, right? Avoid rework, the bane of every developer's existence, right? So we think this will help get folks embracing this. And we want to get out of the world of worrying about mistakes later, right? It's all too often that things go through on exception. These cans get kicked down the road forever. And we want to help you build quality in by remediating mistakes as they're happening, as they're being introduced, and just catching them right away, or as they're becoming known, and making it quick and easy to do that. And the last bit is if you're still one of the folks that hasn't really addressed the OWASP A9 and doesn't have a bill of materials, couldn't tell folks exactly all what's in each of your apps, we want to bring you into the new world where that's just built in, right? Every app as it's being built is getting its bill of materials captured and cataloged so that as changes to what we know about those parts happen, that we know where they're at. And so I'll leave you with a customer quote. Customers always say it best. It's easy for me to talk about, although I was a customer before I came on board. It's just important to know that people that have really embraced this with strong leadership, rolling out the appropriate tooling, really engaging with their developers and security folks to make this work, have seen tremendous benefits. If you think about just the hours of a manual process to approve something and taking that off and making it an automated toll gate, that saved 54,000 hours for these folks at Fannie Mae. And what they found is by driving all of these defects out early, they were able to improve their developer productivity by 28%, which also came with a reduction in cost. And that extra productivity, that's key. That just means you can get more features out, or you can spend more times at bat working on innovations instead of having expensive developer resources working on Jira tickets. So that's it for us. Thank you for listening. Sorry, it's hard to do these things in one take, so it's probably not ideal, but I won't spend a lot of time editing it. Hopefully this will just get this content out there in a nice portable way. Thanks again.